On May 23rd to 24th, Chinese PLA kicked off military drills encircling Taiwan. If that raised explosive tensions, brace yourself for the technological nuclear bomb the United States previously threatened to detonate. 2 days ago, Bloomberg cited sources claiming that the semiconductor giants ASML and TSMC can remotely disable their chip-making equipment if mainland China attacks Taiwan. ASML and TSMC are the undistributed titan of global chip production today. If the claim is true and they went ahead with it, it would trigger a catastrophic breakdown in the worldwide semiconductor supply chain and in turn disrupt digital device manufacturing. This would cripple Taiwan's economy, but it would also backfire and hurt the US economically. That's because so many major American tech companies rely on the chips from TSMC. The surprising part isn't the high level of technology involved, it's not particularly advanced, but rather the questionable intelligence and mindset behind the US issuing such a self-destructive threat. To provide some context, here are the key points. Chinese communications expert Xiang Ligang believes remotely disabling lithography machine is technically feasible, but there are countermeasures against remote sabotage that could allow operations to restart. However, the shockwaves would still be catastrophic for companies and device makers dependent on the chips. TSMC is a civilian company, but the advanced chip it produces supply major US tech giants like Qualcomm, Apple, Nvidia, AMD, a huge chunk of the American semiconductor industry. If TSMC lithography machines were neutralized, there are two monumental issues. One, under what law can ASML cripple a customer's machine? That would decimate their commercial credibility. Who would ever import their equipment again? The temporary edge would quickly erode as rivals caught up. It's a self-destructive plan. If TSMC's operations were paralyzed, wouldn't that obliterate scores of US companies? Wouldn't the entire American chip industry supply collapse? Industry analyst Lin Wen of the China Academy further argues that simply shutting down TSMC may not achieve this intended goal. The crucial parts of EUVs can be reused even after being shut down. As we know, the most crucial part of an EUV machine for microchip production is the optical system, specifically the projection optics and illumination system. These components play a vital role in directing and focusing the extreme ultraviolet light onto the silicon wafer, allowing the creation of intricate patterns that defines the functionality of each microchip. The optical system, including mirrors that reflect and direct light with nanometer precision, is essential for achieving the high level of detail and precision required in lithography processes. Keeping the optical system intact will render the whole remotely disabling technique pointless. Lin Wen also put forward another possible scenario. What if China doesn't need these EUVs by then? In fact, Chinese companies are taking a very different approach than their Western counterparts in building lithography machines. According to reports, Huawei and China's Semiconductor Manufacturing International Co., SMIC, have submitted patents for a chip production method called self-aligned quadruple patterning, SAQP. The SAQP process enables the creation of microchip patterns that have dimensions smaller than what can be achieved using traditional photolithography techniques alone. It accomplishes this through a multi-layer patterning approach that mimics the meticulous construction of an extremely detailed scale model. Specifically, it first deposits an initial layout of wider features and leaves spacing in between to guide subsequent steps. Rail-like structures are then formed on the side of these features to designate where narrow patterns will be placed. Then the initial features are removed, leaving only the rail structures behind, upon which a thin layer of material is deposited to start forming mini-scaled features between the rails. Excess materials are cleaned away to reduce these dimensions even further. The process repeats, adding more rail structures and then selectively etching materials to carve out increasingly finer lines and spaces that can be as narrow as a third the width of a human hair. This allows integrated circuit manufacturers to print vastly smaller circuitry elements than standard photolithography is technically capable of achieving in a single photochemical exposure. Using SAQP, Huawei and SMIC will produce 5nm class processed microchips, which will meet most of the demand. With that being said, the more important message here for the US policymakers is to never look at the Taiwan issue through the lens of semiconductor production. When comparing with China's reunification, these two issues have different levels of magnitude. For up-to-date analysis and on-the-ground sentiments from China, click here to visit our website, thechinaacademy.org, and join our audience community of over 150 million followers.